Ladies and gentlemen, dear rector, dear industrial and academic partners of ours, dear students, dear guests, please allow me to welcome you on our third hydrogen workshop in the history of Hydrogen Technology Research Center, which this time happens to be the first TEDx Salon event in the university's life. So that also marks a new stepping stone that we stepped on the international segment as this is a TEDx event. So today we gathered here not only as participants, or at least I wish that you didn't only come for, as an audience. I think you all are the kind of pioneers in this field, as we hope that hydrogen technology makes you passionate and enthusiastic about sustainable energy, and we hope that you see this as an opportunity to connect to new researches and discover this technological field. So now let me introduce myself. I'm David Kidd. I'm the director of the Hydrogen Technology Research Center, and I will be your host today. And first of all, I would like to invite our rector, Dr. Habil Tamás Fülöp, to give the welcome speech. So please applause Tamás Fülöp.
Thank you, David. Ladies and gentlemen, dear guests and colleagues, and last but not least, dear students. Welcome to the third hydrogen workshop, that is the first international hydrogen workshop event also, and as we can call TEDx Salon event at the John von Neumann University, organized by the Hydrogen Technology Research Center of the university. In accordance with the strategic goals of the John von Neumann University, we decided in 2022 to review and reshape our resources, scientific and research areas, in order to find new innovative solutions. So we do this because we want to become one of the most innovative universities in our country and in Eastern Europe. To this end, we decided that new knowledge centers will start operating at the university. It's our undisclosed goal was our new research directions have tangible and direct social and economic impacts, both in the short and the long term, of course. In connection with the automotive engineering academic part of the university, when we were investigating the research and application of the new types of non-fossil fuels, the topic of hydrogen, next to the electric drive, was among the first to came up in very first time, because our goal is to support long-term sustainability also. Thanks to the dedicated management and staff of the Hydrogen Technology Knowledge Center, serious R&D activities and scientific knowledge dissemination and attitude formation began in the field of hydrogen. So we realized that hydrogen also connects many research workshops and companies in which several collaborations are concrete. As I remember, this resulted several collaborations, and I think today's event also. So as I mentioned, this is the third hydrogen workshop event in the history of Hydrogen Technology Research Center. The aim of the workshop series is to bring people closer to the hydrogen technology in accordance with the international strategic goals, to present them the latest technological developments, thus increasing social acceptance. And for the students, the topic always tries to draw attention in the interesting aspects and excitements in hydrogen technology, to the opportunities of development. The evolution of the event is clearly shown by the fact that it has now grown into the International TEDx Salon event. And parallel, the evolution of hydrogen can be witnessed in the city of Kecskemét. Starting from hydrogen-powered city buses or the latest development of the university, Neumann H2 exhibited at COP28 in Dubai, Kecskemét is now put on the map of hydrogen developments. And talking about the maps, guests arrived today from Hungary, Netherlands and South Korea, which is the first time that this event is international. Today's speakers are partners or scientific network built up in the last 3 years who can present the Hungarian and international hydrogen situation from a broad perspective. Experts arrive from the city government, energy companies, and the heavy industry, vehicle industry, and academic fields also. And because, as our wise predecessor put it, knowledge alone is not enough, research is not enough for itself. We are not able to share or pass our knowledge, it is worthless. If research is only for its own sake, it has no real benefit to the community or to the humanity. This current event also serves a double purpose: to share the result of the latest research, the most modern knowledge, and to serve the social, economic, and scientific impact also. Thank you for my colleagues to organize this event in the name of the collaboration and cooperation. So I wish you a pleasant day and a fun learning experience in hydrogen technology, and thank you for your attention. Thank you.
Thank you, Rector. I totally accept. So sharing knowledge is a very key, and not only for university, but also for industry, even in a technology like this new technology that even some of the society is still not familiar with. So as you can see on the title, basically we split this occasion into 2 sessions. The first one we reflect the situation in Hungary, which is very interesting because you might not even know how well developed pilot projects are already working throughout the country. For that you will see that very relevant speakers came to introduce you that. And in the second session, after a short coffee break, there will be a global outlook, holding presenters from many places of the world, but everything at its time. So I invite my colleague, Erika Varga, to moderate the first session. Please welcome the first session speakers and Erika. Thank you.
Good morning, everyone. My name is Erika Varga. I am the Scientific Project Manager of the Hydrogen Technology Research Center here at the John von Neumann University. We organize this event because we are aware that there are so many difficult questions regarding energy politics and the new trends including hydrogen technology. Fortunately, however, there are experts on this topic and we managed to invite some of them for a nice discussion. Let me introduce them for the first session and I would like to ask them to come to the stage. Péter Sörés is the leader of the MVM Business Analytics Strategy and M&A Group Level Directorate. Please come to the stage. Ákos Kovács is the environmental advisor at the local government of City of Kecskemét. Áron Koronka is the application engineer at the Ganser Compressor Techniques LLC. László Lovas is technologist at the Group of Maintenance and Development at MFGT, Hungarian Gas Storage Ltd. Thank you very much. As a starting point, I would like to introduce some interesting numbers. As some of you might remember that here in Kecskemét in March, there was a trial of hydrogen-powered local transportation. The manufacturer of this test bus, Solaris, delivered 180 hydrogen buses by the end of 2023 and received orders for more than 500 hydrogen-powered vehicles. In my opinion, it is a clear evidence that hydrogen is here. On the other hand, the global energy demand increases by 1–2% annually, and still 80% of which is covered with fossil fuels. Well, I'm sure that in this auditorium, everyone is interested in what's going on in the background and how we could cope with this situation. And our first question to the speakers is related to this topic. First question is, how do you see the actual energy situation in Hungary? In my opinion, at MVM, there are very nice statistics about it. So Peter, could you please start the conversation? You might switch on the microphone.
Okay, I hope it's working. Okay, thank you for the invitation and the first paragraph of this talk. My name is Péter Soros. I'm representing the MVM group in Hungary, from Hungary. That is a state-owned and the largest utility in Hungary. We also own the MFGT, that is the gas storage company, one of the gas storage companies of Hungary. To start this discussion, I think we could just revise the numbers that Erika mentioned. First, let me start with the financial impact of the latest energy crisis of Hungary. We have experienced in the history quite a few energy crises in the 70s, in the early 90s, and last 2 years. The deficit of the external trade balance amounted up to 10 billion euros, that is 5% of the Hungarian GDP. So that's quite a huge amount. We have seen this impact in the inflation and the slow of the even some recession of the Hungarian economy. That's quite a huge impact, and it managed to shape our view on the energy quite different. Hungary is traditionally an energy importing country, so we are currently importing 85% of oil and gas need and almost a third of our electricity need. So it's quite a favorable term regarding the energy supply and the energy market imbalances, what we experience. So we need to continue our progress to move to self-reliance on electricity and other means as well, and also to foster decarbonization. That was already started before the energy crisis. So the coal is currently being phased out from the power generation as well. So by 2025, 2027, there will be no coal power in the electricity mix. And there has been a huge increase in photovoltaic generation. The peak load of the Hungarian system is about 7.5 gigawatts of electricity, and we currently have more than 6 gigawatts of photovoltaic generation installed. So that means that there are quite a few issues with imbalancing and prices and network connections already. So there has been a progress in decarbonization, but we need to move further on. And what we have seen in the previous few years, that could not be continued as was done in the previous years, because we face limitations in network capacity and the total electricity supply as well.
Thank you very much for this nice summary. As far as I know, The city of Kecskemét is also involved in hydrogen and energy strategies as well. Ákos, do you agree with me?
Yes. Thank you. My name is Ákos Kovács, and I am the representative of the local city council. And I would like to talk about a little bit of our perspective of this matter. In short, the situation is bad. In longer, it's really bad. So let's see it. First of all, there is an increasing pressure from the European Union in the way of decarbonization, complete decarbonization. And in the other side of the things, there are different problems raising. First of all, the natural gas energy is pretty expensive. And I'm sure everybody aware that the Hungarian governments and the local municipalities' budget is quite bad. So the only possible way for us now, most of the times, to achieve a new project is that we are very dependent on the European Union tenders right now. The other way, if we want to follow the decarbonization, we have to look for new energy sources, for example, biomass or biogas, hydrogen, or solar power. We're seeing an increasing need in energy in all sectors as well. And also an increasing need in new PV parks, which raises the need for a constant development of the systems through the NVM. And the other problem is that there are really high system usage fees right now. If you want to transfer your energy from one point to another, you have to pay a really lot to do that. And the other problem is that right now, the Hungarian law system doesn't allow us to construct own power lines. So that's an issue as well. Regarding that, we are starting a discussion with the MVM, and we are like to do a pilot project when we would like to create a local energy community. So the locally generated energy would be used at the same place. So in general, we could say that our aim is the decarbonization step by step, while we try to serve the increasing energy needs as environmentally friendly as possible.
Thank you very much. We also have speakers from the technological side, and our next question comes to them. According to your experience, which energy sources and technologies are the most feasible today? Can you introduce any which you are involved in? What kind of difficulties do you have to face when you want to change for a new approach? Aaron, how do you see it from the Ganzer side?
Hello, I'm Aaron Koronka, the representative of Ganzer Compressor Techniques. Hungarian energy mix is very diverse. So there are three key factors which impact on what the energy source is having more importance. The first is the natural conditions. Here in Hungary, the sunshine hours is extremely high, so the PV is in focus. The other is the general concept, so to be as independent from the other countries as we can. The nuclear power and the photovoltaic plants is getting more and more important in the national energy mix. The third one is the functional and technological aspect. The electricity balancing and energy storage is a main challenge here. The green hydrogen can be a reliable solution for this problem. Green hydrogen can be stored longer than the electricity in battery. On this graph, you can find the PV in yellow, and you can see on noontime, the excess energy is a very big challenge to export or use it. The hydrogen can be a very good solution for this problem on the usage side, and also to store the energy in hydrogen. Gonzer's experience is that lots of industrial companies who also feel this challenge.
Great. Thank you very much. Ákos, could you add something to this topic?
Thank you. We have a little experience with photovoltaic parks right now. The plus side is for these parks, they are relatively cheap and easy to maintain. But as everybody can guess, when we have sunshine, these parks are making a lot of energy, which you have to use or transfer. So this asks the question, what do you do with the excess energy you have in daytime? Because if you want to transfer it, then you get another problem, that these peak performances on daytime really stressing the systems. So you need to find a way to equalize it or use it inside. There is one idea we are thinking about, that we would like to use it to electrolyze water and produce hydrogen from it. But this is still about discussion because, as I mentioned, we are highly dependent on European Union tenders, and we have to wait for specific tenders to further these projects. The other thing we are doing now is the Thermostar has finished a biomass reactor in the city, which is a 25 megawatt capacity reactor. It runs on biofuel. It's basically forestation side materials and the locally collected other vegetation. The plus side of that is that it's easy to fuel, and there is an abundant resource locally, so we don't have to transport wood from other directions here. But the downside is that the technology is a little bit dependent or sensitive on the intake, the size of the fraction when you intake the reactor.
Okay, thank you very much. You may transfer the microphone to Peter, to the other side.
Okay, so if we can move maybe back to the slides. One thing may arise regarding the Hungarian energy system, what was mentioned, why the solar generation is an issue here. We have energy storage, but as a natural gas form, so more than 40 terawatt hours of energy, that is the current electricity need of Hungary in a year, that's already stored in natural gas form. So we have quite a few energy storage sites, but with the electricity, we actually basically have no hydropower plants. That would be the traditional form to balance the grid. So that is a plan for the MVM as well, to investigate a pump storage hydropower plant, a possible extension of the Hungarian electricity portfolio, but quite far away from as we started to plan it and investigate the possible sites. So in the next 5 to 10 years, there are no large-scale storage projects from the traditional technologies. The other technologies that are emerging, of course, the batteries, very different form of chemical-based batteries, lithium-ion or any other VRB or sodium sulfur batteries that's investigated in MVM as well, and also as part of the Hungarian energy market players. But these are quite expensive to develop and would not solve longer-term storage problems. We are currently focusing on the day-to-day variations or hour-to-hour variations of solar and generation and demand mismatch. But of course, there should be some form of long-term solution for the seasonal storage needs that comes from the seasonal variation of our available resources. The current solution for this is actually another form of flexibility imports from the surrounding region. We are quite well integrated in the electricity market with our surrounding, with the region. So the hydropower plants from the Balkans, south of Hungary, and from Austria, for example, they are quite heavily, they have quite a few good business models to actually supply countries like Hungary that have no flexible resources available. So it's an interesting development right now. And after we have survived the energy price shock, we see negative prices in the daily prices, and there is quite a large improvement and possible business solution for the storages as well. That's what we need to explore, and we need to further develop with innovative solutions.
Thank you very much. As I can see, we have very nice slides from the MFGT. László, could you please present them?
Yes, thank you. I'm László Lovas, and I'm working for the Hungarian gas storage company. As you know, in Hungary, Magyar Földgáztároló, we are the largest gas storage company in Hungary, and as you can see in Europe, we have a very huge capacity for storing gas, natural gas, and traditionally we are working in this sector, but we're seeing the changes in the energy industry and the need for seasonal storage of energy, and that's why we are started a lot of research and development project in order to find out how to store the energy in the form of hydrogen in a liquid or in gaseous form, using the existing infrastructure, for example, our gas storage facilities, and also new equipments and storage tanks and other equipment. So you can step further. You can see 4 research and development projects in this slide. First one is so-called Aquamarine. It has been started and finished also, and now it's in operation. And in Aquamarine project, we were made a lot of research programs to find out the possibility of and the circumstances of the hydrogen storage problems. The next project has been started and it is finished also, the IUSPRE. I will talk a bit about this project. The task of this project to find out how the underground gas storage sites could be used for hydrogen storage. The next one started at this time, so-called Aquamarine Plus. This is the second phase of Aquamarine project. I will tell you something about it. And the fourth one is EU H2 Stars. This is an EU-funded program in order to make a working underground hydrogen storage project using the existing and new capacities and facilities. You can step further. You can see some details about the project Aquamarine. This is finished, as I said. You can see in this project we settled 2 pieces of electrolyzers which use electricity to produce hydrogen. Mainly our main task was to use the excess electricity which is generated from photovoltaic power plants, and this means this is a cheap balancing electricity which can be used and to produce hydrogen. And also we made the infrastructure to store the hydrogen, to compress and store the hydrogen in a gaseous form in bottles. We can step further. You can see some pictures and plans about this Aquamarine project. It is finished. You can see on the pictures the plug power type electrolyzer, a hydrogen compressor, and on the bottom, and the hydrogen tanks. The test run has been done, so this facility is in working condition, and it is under testing now. We can step further because I'm going out of the time. Yes, we can step, please. Thank you. The next project, the EOH HUSPRE, is started yet. This project is an EU-funded project. In this HUSPRE project, we are going to plan a new hydrogen pipeline from Kardoskút side to transport the hydrogen into a repurposed well, and our task is to inject the hydrogen into the underground gas storage layer. We are going to do a lot of tests and 2 years of test run. And under these 2 years, we will have a lot of experience in gas storage in seasonal form. Okay, we can stop, please. You can see some details about the Aquamarine Plus project. This is a research and development project funded by the government. The first sub-project is LOHC. It is a liquid hydrogen storage program. The second one is a control technology project in which we are repurposing the existing gas engines to use hydrogen as a fuel. And the third one is a hydrogen-resistant coating development, internal coating for gas pipelines. And the fourth one is the compatibility and conformity assessment procedure development in order to find out how the existing infrastructure can be used for hydrogen purpose and how the pipes and equipments can be used. We can step further. And the last one is the EU, of course. In EU H2 STARS project, you can see some pictures about the planned site development. And I would like to say that we have an existing gas storage facility in Kardoskút with a separated layer, and this small separated layer in the picture in the middle will be used for storing hydrogen and gaining it back and for utilizing. And we can stop. Thank you.
Thank you very much. I can add that I have already visited this aquamarine plant, and it is rather fascinating. And ladies and gentlemen, we have already arrived to hydrogen, and we are going on. Third question. What role do you think hydrogen can take in our energy mix? What are your plans for the near future? Ákos, can you please?
Thank you. So about the future plans, the municipality aims to further diversify our energy portfolio, and we are like to complete the decarbonization process by 2030 or 2040. That's the goal. Right now, about hydrogen, we are planning to decarbonize the whole local public transportation system. Right now, we have 25 hybrid buses and 45 diesel buses. But the City Council already approved of the purchasing of 2 new hydrogen buses at the start of 2025 and 8 more at the start of 2028. In the meanwhile, we are planning to upgrade and change the already existing 25 hybrid buses by this time. And the final project for us, which will yet to be seen how to be managed, that we would like to solve the problem that these new hydrogen buses need to be fueled by hydrogen, and we would like to find a profitable and sustainable solution for that to make our own hydrogen and tank these buses. So that's our plans for the near future.
Thank you very much. Peter, what do you have at MVM?
We are also working on numerous innovative hydrogen projects, and we are trying to develop the infrastructure that's needed for this hydrogen generation and hydrogen infrastructure. But I may cite the Hungarian energy plan, the energy strategy, the National Energy and Climate Plan that was revised last year, that's already including quite a huge role for hydrogen, not in the next 2 or 3 years, but by 2040 and 2050, that we see that in the government plans, we have a substantial role for hydrogen, especially in the transport sector. We see that if we are trying to compete hydrogen technology with other already established form of energy supply types, for example, piped natural gas or electricity. So if we compare kilowatt hours to kilowatt hours, that could be a very competitive area for hydrogen. But if we move further along the value chain and we try to identify the exact need for energy supply, for the previous example, that's actually the mobility, the service that is needed for or catchment or for the people themselves. So if we try to move along the value chain, we can identify use cases that could be interesting for an emerging technology for hydrogen as well. That's one specific is the transport sector, and especially with the heavy-duty vehicles and larger buses and so on. We see that the battery-based solutions, the fully electric solutions are rapidly emerging in the passenger-sized or small-scale vehicles, but the debate is very on regarding the supply of larger vehicles. All in all, we will see that the industry and the transport sector will need the most amount of hydrogen in Hungary as well. And the main question is how we generate this hydrogen. So that's the huge concern for most electric utility and gas utility like MVM, how we can generate this energy needed for the hydrogen generation. It is expected that the hydrogen generation itself will need around 10 or more than 10 terawatt hours of electricity if we are going to generate this from the network transported electricity, and that is around the 1/4 of our current electricity demand. So it's quite a huge demand right now. So it's going to be an interesting strategy or what is evolving regarding hydrogen, how we can supply the hydrogen industry enough electricity, and whether they have enough technology advancements to use this electricity supply only when it's quite cheap. So when the sun shines, there will be quite a few cheap solar supply. The main question is whether this is enough for the hydrogen generation sector.
Thank you very much. Well, as far as I know, Ganzer is interested in and works in the field of hydrogen. So, Aaron, please, could you give us some details?
Yes, thank you for the question. Ganzer supports companies, industrial companies, how they can apply the hydrogen to their energy mix, or also use it for production purpose. We were involved lots of feasibility studies regarding this to form a concept for the companies, how they can store and use the energy, and also we can offer technical solution. For example, here is an example from a city council. which has existing PV plants, the excess electrical energy appears. They want to use it and store it also, and they want to use it for CHP, so combined heating and power direction, to heat up sports hall and society buildings. And also there are a lot of available fuel cell vehicles, for example garbage trucks or street sweeper cars. They want to fill up these with hydrogen. Yes, can you show the next? Thanks. On this layout picture, you can find this how complicated the system is. So Gonzer has this deep experience how to integrate the units into a whole system. And this is very big challenge because every little details is very important, and every little unit has their own communication and properties, and Gonzer as a system integrator knows how to fine-tune the system. Next slide, you can see the Gonzer starts a new research and development project, which is a 1 megawatt electrolyzer, because our experience is that there is a certain layer from this industry segment who wants to use and apply the hydrogen, and we want to satisfy this sector of the industry. My colleague Achilles will talk about in detail from this electrolyzer in the next session. Thank you.
And we have arrived to our last question, just in short. Which factors through the hydrogen value chain do you think limits the spread of hydrogen energy? Laszlo, please.
Thank you for the question. I think a lot of factors influences the price of the produced hydrogen. At first, the system cost, but we can see the cost of the equipment and the labor is increasing, and in the last 3 or 4 years, it is doubled. So we can see a significant price increase in the cost of the implementation of the system. And also, very important is the price of the electricity if we are going to produce the hydrogen from electricity. Maybe you know that the price of the electricity in the market, in the industrial market, is not a fixed price. It is changes daily due to the excess energy and due to the negative energy demand. In case of a lot of solar panels are in operation, a lot of excess energy is produced, so in this way the price of the electricity is going to be lower. But the main problem is that the period of the low price electricity, so-called cheap green electricity, is very, very short. So daily we have only a half an hour or 1 hour to utilize the cheap green electricity. So these are the main problems. If we are going to operate in the whole day, we have to use the higher price electricity which is gained from the market. So these are the main factors, I think. Thank you.
Thank you very much. Aaron, please, could you comment on?
Thank you. Our experience is that the regulatory authority is not completely prepared for help the segment to accelerate this transition for this direction. So Hungarian industry needs real projects and more funds to accelerate the expansion of this hydrogen industry. And the last but not least, we can see the fossil energy sector is a very well set up and strong segment on this energy industry. And the key users only has to operate the system, and not very serious problems, or they don't have to invest a lot. In contrast with this new technology, the capex cost is very high, and it's a long-term investment, and this doesn't sound so good. So that's why the whole energy sector needs a complete mindset changing to reach our goals. For example, the national and the Hungarian strategy, or the European hydrogen strategy. Thank you.
Okay, thank you very much. Peter, how do you see this question?
There are a lot of challenges and also opportunities ahead of us. One challenge that could be illustrated with this slide, the next slide, that we need to address the issue of the conversion factors. So maybe it's not the best illustration for this issue, and maybe not the best citation I could get for the conversion factor issue, but we see that if we are going to massively rely on hydrogen technologies, there should be much more primary energy available from the supply side. So we need more and more electricity. So the hydrogen is competing with other emerging and other developing technologies, the electricity-only pathways and other gas-based pathways as well. So it's interesting to see that if we are facing with negative prices, of course the conversion factor is not an issue. But if we are facing the prices that we have experienced 2 years ago, that was all-time high energy prices for all sources of electricity, all sources of energy, then it's a very grave issue for this technology. So the key here is whether we can reduce the conversion losses in the hydrogen economy, and also the other part is the capex or capital expenditure intensity of this technology, but that's quite similar to other clean energy technologies, so it's an economic issue, especially for developing markets like Hungary, how we can finance such a large amount of investments in our energy sector. That's not specific to hydrogen, but of course hydrogen is not advantageous of this aspect as well. So these are the key challenges ahead of us.
Thank you very much. Ákos, could you add something?
Yes, well, the gentleman's already said everything, I think. Maybe one thing to add from the buyer's perspective, that as I was mentioned before, as a municipality, we don't really have a budget to finance these very highly expensive projects. So our only choice is to waiting for good European Union tenders to do so.
Thank you very much. Thank you very much for the nice summaries and the nice discussion. I think you have mentioned practically everything that can be important and interesting. And maybe technology development may provide solutions for the aforementioned challenges, and some of them will be presented in session 2. So session 1 is finished. I think we are quite good in time. So the stage is open for some questions from the auditorium. If you had some questions, please, or you can discuss it with the speakers during the coffee time, coffee break. I was sure that you will have one.
This question is for every one of you who can actually answer it. So you mentioned that you have high capex, but how about OPEX? So do we have enough experience already to say that this is financially can be sustainable from the OPEX side? I mean, labor, does it require much maintenance cost? How do you see this, especially for producing hydrogen?
Thank you for the question. I have only one word. As we use our own employees, the working costs are easy to calculate because we utilize the manpower of the existing colleagues, as I can see. But in the construction, we see that the labor cost of foreign companies who are working for us is also increased. So if somebody wants to use foreign employees, the cost is increasing, of course, and that means the operating cost is also increasing due to the manpower cost. And we also talked about the electricity and the energy cost, so that is varying. Thank you.
This is a really good question because you mentioned some form of risk that was not mentioned yet. So, regarding the financing, that's a very important issue. How we can plan what is the risk of operating such technologies. So, maybe we can have some form of grants or subsidies for the CapEx, but for the OpEx, it's quite limited and not really possible regarding the current EU stated laws. So it's an interesting question. So our aspect is we would like to get offers from technology providers that would include servicing contracts and O&M contracts as well. So the total cost should be complemented with, for example, 10-year operational cost as well. So it's a risk for the business planning and a risk for the technology as well. So I advise for everyone that this should be included in the development of the products as well.
At least for 10 years from installation.
Yeah, because the financing is for these technologies should be at least 5 or 10 years. So actually, if there is some risk regarding the operational capabilities and the OpEx of such technologies, then it would translate into a less favorable investment terms, and so this risk would be somehow priced in the decision. So it's better to have the technology providers or any other capable parties to actually write down and guarantee some of these risks, and this could be quite a good starting point for all of the commercial projects for hydrogen. And of course, this should be explored in the development phase as well, because I'm an engineer as well, so I understand that there are quite a few risks regarding a longer term operation of such innovative technologies, but this should be mitigated somehow, maybe to an insurance or something like that. But it's a really key issue for just motivating everyone in the decision area to actually believe in such projects.
Thank you very much. If there aren't any further questions, let us have a break. Oh, there is one.
Just regulatory side, there is a regulation that the alternative fuel infrastructure regulation that prescribes some hydrogen stations as well. So we need to build them. I don't know what would be the finances for that, but MVM Mobility is also aiming for some part of the hydrogen economy as well. But the actual technological issues is quite huge, I think.
Yes, I just wanted to say about this question that we have European hydrogen strategy and Hungarian hydrogen strategy too, and the numbers I write it down. So till 2030 we have to build up these hydrogen refuel system stations, but I agree with Peter that we are on the first steps now, but we will provide these because of the strategies, write it down correctly. Thank you.
Thank you. Okay, then let us have a break. And we are moving on to session 2 at 10:30.